Hello everybody, this is our video number 1 and from this video we will start a new chapter, that is the limit and the derivatives. So this chapter is very important as per our class 11 and as well as the class 12, because if you consider the definition of the limit, the fundamental concept of the calculus, where we analyze the behavior of a function at the neighborhood of a particular point. Okay, so this is the mathematical definitions of the limit, and limit is also called the entry point of the calculus. Okay, so for our better understanding, we take an example. Suppose we consider a function fx, okay, and this fx is defined as the x square minus 16 by x minus 4, okay, and if you put x equal to 1, what is the value of this function at x equal to 1? This time this function produces the 5. Similarly, f of 2, this function produces the 6. F of 3, this function produces the 7. And f of 4, this function produces undefined value, that means infinity, or undefined value, that means the 0 by 0. If you put the 4 in place of x inside, the 4 whole square minus 16, 4 minus 4, that means it is produced the 0 by 0 value, and this is nothing but a undefined value. So when we put x equal to 4 in this function value is undefined. That means at x equal to 4, this function violates the protocol of the function. So this is a big problem to satisfy or justify it is a function or not. And to solve this problem, we introduce the limit, and that means the limit is a process to calculate the or justify, analyze the behavior of a particular functions of its neighborhood point of a particular point. So if you consider the number line, so this is our number line, and suppose this is the point x equal to 4, okay, and this x equal to 4, the function value is undefined. So this time, if I want to find out the value of this function, then we consider the neighborhood point of this 4. This is very closer to this 4 but not equal to the 4. So this time we consider the some value which is present the left side of this 4. Suppose this time we consider 3.8, 3.9, 3.99. Consider that this 3 point, which is neighborhood point of this 4, and it is this, all this value of this point is very closer to this 4 but not equal to the 4. After that, find out the value corresponding all this value which is present the left hand side of this 4. So at 3.8, the value of this function is 7.8. 3.9, the value of this function 7.9, and the function is fx is equal to x square minus 16 by x minus 4. Okay, and if you put the 3.99, then this function produces the 7.99. Okay, so if you observe all the value, then all the value which is closer, very closer to the 4 but not equal to the 4, and with respect to all those points, this value, all the value of the function tends to a definite value, that is the 8. So when the value of x is tends to 4 means all the value is nearly or very close to the 4 but not equal to the 4. The function value is tends to a particular value. This is 8. Okay. Next, we consider the value, some value which is present the right hand side of this code, and same criteria, all those value which is present to the right hand side of this code, it is very closer to the 4 but not equal to the 4. And this time we consider the 4.2, 4.1, 4.01, and find out the value of function corresponding this value. This time the 4.2 is produced 8.2, 4.1 it is produced 8.1, and 4.01 it is produced 8.01. So this time when you consider all the value which is closer to the 4 and belongs to the right hand side of this code, then this function is also tends to 4 from right side, this function value also tends to a particular value, this 8. Okay, and this time when a function behaves just like that, if you consider the sum value, that means if you consider the sum value which is present the left hand side of a particular point and the sum value which is present to the right hand side, and all those values very closer to this particular point, and when we move from the left to this point, this function value this tends to a particular value, and also when you move from right side to that particular point, this means the 4, and the function value also tends to the same value. This time we write this notation, the limit x tends to 4, fx is equal to 8. That means the limit of this function fx, when x tends to 4, the value of this, the limit of this fx is equal to 8. Okay, and from this pictorial representations we also derive another concept, that it is called when the value tends to 4 from the left side, then this time this is called the left hand limit. And when the x tends to 4 from right side, this time it is called the right hand limit. Okay, and notation of this left hand limit and right hand limit is the limit x tends to a minus fx. This is the notation for the left hand limits, and the limit x tends to a plus fx. This is the notation of right hand limit, and when these two are equal, that means the value of the left hand limits is also tends to a particular value, and the value for the right hand limit for a particular function always tends to a particular value. This time the limit exists for this particular function at a particular point. This is the concept of the limit. Okay, and in this way we can easily find out the limit of a particular function with respect to a particular point. Okay, but sometimes it is very tedious and a long process to find out the limit for a particular function of a particular point. So to overcome this problem, we use the sum method to find out the limit of a particular function of a particular point. So method of finding limits. So first method is the direct method. Second one is the substitution. Third one is factorization. Fourth one is rationalization. Fifth one is our normal process, that means the left hand limit of a particular function is equal to the right hand limit of this particular function. This five method mainly used to find the limit for a function of a particular point. Okay, and also use some predefined formula to find out the limit. Next, algebra of the limits. The first one is limit x tends to a within bracket, so fx is equal to the limit x tends to a fx plus limit x tends to a gx, and it is also applicable for the subtraction. Okay. Second point, the limit x tends to a fx into gx, it is equal to the limit x tends to a fx into the limit x tends to a gx. Okay. And the last one, the limit x tends to a fx by gx, it is equal to the limit x tends to a fx by limit x tends to a gx, where the limit of x gx at x tends to a is not equal to 0. So this is our third algebra on limits. Okay. The fourth one, a limit x tends to a lambda fx is equal to lambda limit x tends to a fx. This time lambda is any constant. So mainly use this four algebra of limits. Okay. After that, we use some predefined formula to solve or to find out the limit of a particular function. The first, limit x tends to a x to the power n minus a to the power n by x minus a is equal to n a to the power n minus. Also use the limit x tends to 0 sin x by x is equal to 1. This is 1, this is 2, this is 3. Limit x tends to 0, 1 minus cos x by x is equal to 0. Okay, so with the help of this predefined formula on limits and also use all those methods, that means the factorization method, substitution method, the delete method, rationalization method, and also after that compare the value for the left hand limits for the particular functions and the right hand limits, if both are equal, then this time the limit is exists for this particular function at this particular point. Okay, and these are the brief introductions on limits. That's all for the today's lecture. Thank you everybody.